In this lesson on significant figures, we're going to look at what counts as a sig fig. So what is significant and what isn't. You have the rules in the lesson, in the course, and this is really just an overview, walking through them and giving you some examples. These guidelines are going to become very important in Chemistry 11, and you are going to have to be able to look at a question and all the data and determine how many sig figs there are in each value. And then later you're going to use some rules to help you determine how many sig figs you're allowed to have in your answer. But the first step is just figuring out what is significant and what isn't when you're looking at a number. So we're going to go through a few guidelines, and I'm going to give you some examples as we go. Trailing zeros with no decimal place are not significant. So here's our first guideline. That means that the number 100 only has one significant figure. Okay, and I'm going to circle it here. These last two zeros, the trailing zeros behind the number, are not significant. There's only one sig fig in this question. If I had a decimal place after that last zero, then all three digits would be significant. Let's do another example. Okay, the number 5,000, let's say actually 52,080. Okay, if I look at this value here, my first four digits, 5208, are significant, but my last zero is not significant. So the first four values here are, sorry, the first four digits are, so we have 4 sig figs in this value, but that last zero does not count, it is not significant. Coming back for just a moment, thinking about what sig figs are, you read in the lesson, sig figs are a way for us to express precision in a measurement. So any value that we're looking at, we assumed it was measured in some way. And anything that we measure, we will report down to the last unit that we were able to measure. So when we don't have a decimal place there, it tells us that we really were not able to measure past this unit right here, okay, a tenth, number 10, or in this case, to 80. But this one here is really just sort of our guess digit, and therefore it's not significant. If I were to put a decimal place there, it tells me, oh, in fact, I was able to measure right down to that last digit, and therefore all of the digits before the decimal place would be significant, and as well as any after the decimal place as well. Let's do another couple of examples here. So let's use a quite a large number. Let's say the number 6 billion. Okay, if I don't have any decimal place in this value, then only the 6 is significant. Okay, all of the zeros trailing on the right are not significant. So there's only one sig fig here. But if by contrast, I had the value 6 billion and 1, because I have this 1 here, it tells me that I was able to measure right down to this last digit, and therefore all of these digits are significant. So I've got a total of 10 sig figs here in this value. Trailing zeros are not significant when there's no decimal place, but when you have a decimal place, they are significant. So for example, if we had 100.0, not only is my 1 significant here, but because I've got that decimal place there, it indicates that I was able to measure right down to a tenth, okay, so that all of these digits are significant. These were all measured, and therefore I have 4 sig figs in this value. Another example would be, say, something like 3.0000. Okay, again, that decimal place and the 4 zeros that follow it are a way of expressing that we have precision right up to that last decimal place. Okay, so it's not just the number 3, it's 3.000. So I have 5 digits here, and all of them are significant. I often think in terms of precision as if you were a researcher or a chemist and you're reporting data in your lab or in your research, you would put a decimal place and values after only if they were meaningful. So anytime we see a decimal place, there's a reason for it. It's to say all of these numbers to the right of the decimal place were measured. They were measured and they are therefore significant and meaningful. Let's do another example of this. Trailing zeros with a decimal that are significant. So let's say, for example, we have 501.020. So here, I know that my 501 are significant, and because I have a decimal place here, all of my digits to the right are significant also. Okay, so I've got 1, 2, 3, 4, 5, 6 significant figures here. Okay, all non-zero digits and zeros that are trapped in between numbers are significant. So it's obvious to us that non-zero digits are always significant. So for example, in the number 55, we know to measure or to count both digits there as significant. So there'd be 2 sig figs there. Okay, but the number 505, again, we would be measuring from the left or reading from the left to the right, and we've got 2 non-zero digits with a 0 in between. All 3 of those are significant. And this isn't so much a rule as it is common sense. If you have a 0 trapped in between numbers, that's fine, but you know that you were able to measure right to that last value or that last digit, so therefore all the digits to the left of it would also be counted as significant and meaningful. Another example would be something like this. Let's say 6.2008. Okay, again, going from the left to the right, my 6 and my 2, as well as all the digits to the right-hand side, okay, all the way up to the 8 are all significant there. The zeros also count 1, 2, 3, 4, 5, 6 there. Okay. Leading zeros before a digit are not significant. So most often we see these when we have a decimal place. It's pretty uncommon to write something like this. You know, the number 10, we don't usually put a 0 in front of it, simply because it's just not standard practice. So most of the time when we see leading zeros, we see them with a decimal place. So for example, 0.12. Okay. So this first 0 is not significant, but the digits 1 and 2 are. So we would have 2 significant figures there. Another example might be something like this, 0.00007, okay, has 1 significant figure here at the end, but the leading zeros are not significant. Only 1 sig fig there. A rule of thumb here, when you're looking at a number that's less than 1, is to start counting from the left. If I were to count from the left to the right, I would start here on the left with a 0, and until I see a non-zero digit, I don't start counting sig figs. So you can skip all those leading zeros until you see a non-zero digit. So to give you an example of that, let's give you a different number. Okay, 0.00007010, starting from the left. Okay, until I hit a non-zero digit, I don't start counting. So I'd start to count at the 7, and all of the digits to the right of the 7 would be significant here. Okay, we do have a decimal place, so trailing zeros are significant, and so here I've got 4 sig figs. One of the reasons why leading zeros are not significant is if I were to take, say, this number right here, and I were to express that number in scientific notation, if I were to do that, I would move my decimal place over to the right 1, 2, 3, 4, 5 times. So I would have 7 times 10 to the negative 5, because I've had to move it over to the right. And you can see when I express it in scientific notation that there's really only one value here that I'm reporting. Okay, so I've got 1 sig fig. When I express it in scientific notation, sometimes it's helpful just to take a number like that, if it's very large, very small, put it in scientific notation for yourself and see how many digits do you actually have that are significant. Let's talk a little bit about scientific notation, the last point here. Exponents are not significant. So when you express something in scientific notation, or it's expressed, you're reading a value that is in scientific notation, the exponent is not part of your sig figs. So for example, I've got the number 5.0 times 10 to the 2 sig figs. There are, 5.0 times 10 to the 2, there are 2 sig figs here, the 5 and the 0. Okay, that exponent, this part right here, is not significant. These are not sig figs. Okay, let's take it out of scientific notation for a moment, and we'll move that decimal place over 2 times. So times it by 100, we get 500, and we'll have to put a decimal place there. Okay. Oh. Sorry. Let's take a look at exponents and talk a bit about them in terms of significant figures. So exponents, when you write a number in scientific notation, the exponent is not significant. So I've got some examples here. These are in the lesson. 5.0 times 10 to the 2 has only 2 significant figures. Okay, the exponent times 10 to the 2, this part here is not significant. So these are not sig figs. Similarly, the number below, 4.13 times 10 to the negative 4, has 3 sig figs, and the 10 to the negative 4 is not part of the significant figures. I could take this value right here and write it out. Instead of in scientific notation, I could move that decimal place over 4 to the left, and I would get 0.000413. And when I write it like that, you can see, using our guidelines, that those first leading zeros would not be significant, and only the last 3 non-zero digits would be sig figs. So here I would have 3 sig figs. A little note about scientific notation. It is extremely helpful when you have to report your answer with the right number of sig figs. I'll give you an example of this. So, for example, let's say we measured a solution, and we measured that it was 500 milliliters. Exactly. I was able to measure it right down to the last milliliter, but I didn't have a measuring instrument that allowed me to measure to a tenth of a milliliter. So I'm measuring it to right here, and I want to say that it's not 499, it's not 501, it's exactly 500. Well, one of the ways I could do that is I could put my decimal place right there after the last zero, and that would tell me that there are 3 sig figs. As soon as I put that decimal place there, it tells me to count all of the digits there before the decimal. So this would be okay. It's not great because it would be easy for anybody looking at my data to maybe overlook the decimal place. If I didn't write it clearly, it's quite easy for them to look at that and think, oh, no, that's only 1 sig fig if they don't see that decimal place. So an even better method would be to write this in scientific notation. So if I wanted to report exactly 3 sig figs, I could write it as 5.00, okay, times 10 to the 2, and I would still have 3 significant figures. There's my 3 sig figs, but I'm able to show that indeed I was able to measure it right down to that last milliliter. And this would be better. All right. In the next several lessons, we're going to talk a bit more about sig figs, how to use them in calculations, and what the sig fig rules are when you're carrying out a calculation. But for now, you want to get used to just being able to recognize how many sig figs do you have in a value. So go ahead and do some practice questions with that.